In this video, I will show you how to conduct a one-way analysis of variance in SPSS. This dataset includes three variables. The first one, called ID, is just a numerical identifier for all the individuals in the dataset. And this dataset consists of 75 students. The second variable is a categorical variable called instruction, which shows the type of instruction that students received. And we have three categories for this variable. If we go to the Variable View tab, we can see that the instruction variable takes the value 1 for online instruction, the value 2 for hybrid courses, which consist of both online and face-to-face meetings, and the value 3 for traditional instruction or face-to-face courses. The third variable, post-test, includes students' test scores after instruction was delivered, regardless of the instructional method used. The null hypothesis here is that there is no significant difference between the average scores of the three groups. To conduct the analysis of variance, we have to go to the Analyze menu, then choose Compare Means, and then One-Way ANOVA. On the left side, we have a list of all the variables in the dataset, and we have to select the variable that we are testing across the three groups. In our case, this variable is the post-test variable because we're comparing test scores between the three groups, so this will be our dependent variable. Then we have to select the variable that shows to which group each individual belongs to, and in our case this variable is the instruction variable, and we have to select it and then move it in this area called factor. We also want to see the actual means and standard deviations and sample sizes for each group, and for that we have to go to the Options menu and then choose the box next to the descriptive statistics, and then click Continue. If the test statistic is significant, we also want to see where the significant differences occur. So we want to conduct some post-hoc analysis. To do that, we have to go to the Post-Hoc button, and from this list, I'm going to choose the two-key procedure, and then click Continue, and then click OK. In my output window, I have three tables. The first one is the Descriptives table that I requested. So for each category, online instruction, hybrid, and traditional instruction, we have the sample size. We can see here that we have 25 students in each group and a total of 75 students. The mean for each group, we can already see here that the students in hybrid group had the highest mean, followed by students in the online cohort and then students in the traditional instruction cohort. We also have the standard deviation, standard errors, the 95% confidence interval for these means, and also the minimum and the maximum values in each group. The second table is the one that is the most important because it provides the results of the test of significance. Because we have three groups, the between groups degrees of freedom is equal to 2. 3 minus 1 is equal to 2. The within groups degrees of freedom are equal to the sample size minus the number of groups. So 75 minus 3 is 72. And the total degrees of freedom is 74. This is the result of subtracting 1 from the sample size. 75 minus 1. The test statistic, F, is the result of dividing the between groups mean square by the within groups mean square, which is also called the error term. The p-value for this test statistic is 0.001, which tells us that the differences between these three means are statistically significant because the p-value is lower than alpha of 0.05. Now that we know that the differences between the three groups are statistically significant, the next question is, where do these differences that are statistically significant occur between which groups? Are all the differences significant or only some of them? To respond to this question, we have to look at the results of the post-hoc analysis. The Tukey procedure computes differences between all of the groups and tests whether or not these differences are statistically significant. In this table, we have, for instance, the differences between online instruction and hybrid instruction, online instruction and traditional instruction. In the first column, we have the actual differences between the groups. Then we have the standard error for these differences and the p-value for all of these differences. The p-values that are statistically significant at the 0.05 level are marked with an asterisk. So we can see in our example that hybrid instruction and traditional instruction are statistically different. The other difference that is marked as significant is actually the same difference between traditional instruction and hybrid instruction. The Tukey procedure also creates subsets of groups that are similar. The subsets include the groups that did not have means that were statistically significant. In our case, the first subset consists of the traditional instruction and online instruction group, which were not significantly different. And the second subset consists of the online instruction and the hybrid instruction group, which were not significantly different.